Hi everyone. So today I'm going to talk about the actual state-of-the-art of Ethereum smart contract fuzzing. So my goal with this talk is basically to give you an idea how exactly an Ethereum smart contract fuzzer work, what's the key features that make a fuzzer a good fuzzer, and ideally to tell you a bit more about the actual tools that you have on the market and which one are, for me, personal opinion, the best and what can be done to improve them. So a quick intro. So I'm Patrick, I'm the founder and CEO of Fuzzing Labs. So as the name suggests, we are doing fuzzing full-time. So fuzzing and vulnerability research, mainly on layer 1 and 2. We are also providing training regarding Rust, Go, security, and so on. And maybe you heard about one of my main projects that was Beacon Fuzz, the Ethereum 2.0 differential fuzzer for consensus clients. So what is the actual state of the art? So first of all, I need to explain what is fuzzing, just to be sure everyone is aligned. So fuzzing stands for fuzz testing. So it's actually the most efficient technique to find bugs on program in general. The main idea is to provide random or pseudo-random input into a program, monitor if it's crashing, and if it's the case, it's a good point for you. There is different type of fuzzer. The first one, different approach. The first one is black box, so you don't have any information about the target. The second one is gray box, meaning you have a bit of information of maybe what kind of input you are taking inside the program. And the last one is white box fuzzing, meaning you have the source code of the program, and you can basically modify the program, recompile it, and do some other stuff. So the way it works usually is you are providing input, you are executing the target, you need to find out if there is any crashes, or you can have like detectors that will detect something weird is happening. And then you will do that over and over again, like a big infinite loop that is doing the stuff. So over the time, we saw multiple fuzzers. So I made a quick timeline. One of the first one was Echidna. Then we got some fuzzer like contract fuzzer, chain fuzz, like almost every big security Ethereum-based company have been creating its own fuzzer. We also have Harvey. So I put it in 2020. To be honest, it was more in 2018. It's just that they released some like public services at the time, and you will see later it's closed source. Recently, we got Foundry that support fuzzing. I will discuss more about that. And a quick shout out to fuzzing like a degen. It's definitely not a really efficient fuzzer and so on, but it's really nice that people start to just try to publish some new stuff and learn more about fuzzing for people in the ecosystem. So quick overview, first of all, which one is open source? So almost all of them except Harvey, and you will see that it's a recurrent stuff. Then we have the language of development. That's something I think is really important because if you are writing the stuff in a language not like Haskell, for example, you will also have people that will learn more about the internal of the code and maybe try to improve the stuff, and it will basically make it better and better over the time. So a bit red flag for Echidna in that case, because I don't know how many people are familiar with Haskell, but at least not me. Then we have Harvey, I don't know, unknown. We have some Go, we have some Rust, and also some Python. So for me, that's the main language that we should develop further in. In terms of documentation, we have Echidna and Foundry that are really well documented, and it's even more in the future, I think. And the other one not. And the last point is it maintained or not? That's something really important, especially if you want to start to learn how to use a fuzzer, and this fuzzer will be updated over the time, fitting with like the new opcodes and the new stuff that will come in the ecosystem and in the smart contracts. So that's also something that is really like a key point. That's where you see that contract fuzzer and chain fuzz are actually not maintained anymore, so deprecated. But there is still some interesting stuff to learn from them. So let's see a bit more about the fuzzer internals, how exactly a fuzzer works. So the first feature that you need to have is the input generation. In our cases, the inputs that we're going to generate are basically transactions, and there is plenty of stuff we can generate from that. So the first things to generate, of course, it's the transaction itself and what we call the call data. So you can perfectly leverage on either the Solidity source code, the ABI, to basically learn more about the type of argument and generate the transaction that way. But even if you only have the bytecode, it's the case if you are doing like black box fuzzing, you can still leverage on that and learn directly from the bytecode. Typically, you take a look at the 4-byte, the function ID, the method ID, directly inside the bytecode, and you will be able, first of all, to find the method ID, and also you can use some reverse DB database to actually find out the parameters. So as you can see in this example, for example, right there, if we want to trigger the assert, we will need to generate the proper value for A and the proper value for B. So that's typically something that the fuzzer will be really efficient to do, and we will be able to generate pretty easily. Then we can generate some sequence of transactions. That's something really important and not done by all the fuzzers. The main idea is, since after each transaction you will modify the internal state of the contract, by doing a sequence of transactions, you will be able to trigger some part of the code and some state that was not discovered previously. Tiny example is the famous Rubik C contract, and in that case, if you want to exploit this contract, first it was needed for you to call the dynamic pyramid function and then collect all fees. So if you were just calling one function at the time and just reset everything and reset the state of the smart contract, that's typically a vulnerability that you will not be able to find automatically by using fuzzing. So regarding our competitors right there, we can see that most of them, the requirement is actually to have the source code in order actually to determine the method ID and so on. So that's the simplest way. Only one of them was using only the bytecode. It was a contract fuzzer. And what is a bit more interesting is the input generation. What you can see is almost all of them was actually generating both and using both a technique for input generation, so both the call data generation and at the same time the sequence of transaction. And what you can directly see in that case is that Foundry, for the moment, is only generating a single transaction. So that's where you see that we start to have some limitation in the different fuzzers available, and that's definitely a point that should be improved in the future. Another really important feature is actually the execution engine. So we are generating transaction, we are giving that to the EVM, and the main question is, does this EVM is part of a local network that you are running, or is it possible for you to directly provide that to the EVM itself and get more execution speed? That is one of the key metrics when we are discussing about fuzzing. So in case of local testnet, you can easily implement that using Ganache, for example, and you will basically have your internal network, and you will provide the transaction, usually using the APIs and the libraries that are provided in Ganache. I don't remember the name, but whatever. And that's okay. It's working really well. It can be done really easily. That's typically what Fuzzing Like a DGen was doing. It was a fuzzer developed in like 4 hours during a Twitch stream, and basically that was the technique he was using. What is way more efficient and way more interesting is directly to provide the transaction directly inside the EVM. So you will only execute the EVM alone, and the main purpose for us will be to get way more execution speed, because you will provide the argument and it will be executed. You will keep the state and go on and so on. So you provide directly the transaction to the EVM, you execute the contract, you get new state, and it's way more faster. So what we can see there is that Echidna is actually using HEVM, so written in Haskell as well. So that's maybe a reason why Echidna have been developed in Haskell in the first place. And then we have some fuzzers that are actually using like a local testnet, like ShaneFuzz, Harvey, and fuzzing like a dgen. For Foundry, they implement their own Rust version of the EVM, and that's also why Foundry is really fast and really interesting for us, because we are getting way more speed using that. The third point that are really interesting is the detection mechanism. How do you identify a bug? So in that case, you will need to do that directly at the EVM level. You need to have a way for the virtual machine to tell you, okay, there is something wrong that happened, and you need to actually notify you as a user that something wrong occurred. So you can perfectly, first of all, leverage on all the exceptions that are directly inside the VM. So that's the exceptions that are actually detected at runtime by default by the EVM. You can think of when you are using stop, revert, self-destruct, all those kind of opcodes. You also have all the stuff like out of gas, illegal instruction, assertion failure, and arithmetic overflows. Those stuff are detected by the EVM. So for us, it's directly detection mechanism for free because it's part of the EVM design. Another point that I think as a user are the most common one is actually to do property testing. So what most of fuzzing framework on Ethereum actually ask you to do is to write what we call invariant, or at least testing function. So that means you will need to write in Solidity some functions that will be there to test some particular properties. So that's really nice, but that requires some manual job for you to do. You will need to actually understand the smart contract, write your own property testing, and based on that, you will do the fuzzing and expect maybe an assertion to fail if something wrong happens. So, of course, almost all the fuzzers are actually leverage on the runtime exception, because, as I mentioned, that's some free stuff for us. And for the property testing, it's a bit more particular. It's really depending on the design of the fuzzer. As I mentioned, if the fuzzer is actually taking some source code as like leveraging on the source code, you compile the source code for the fuzzer, and then the fuzzer is running on top of that. That's also why they need the source code, because they will take in consideration the function, the testing function, where if you are only fuzzing the bytecode, you will not get any testing function directly like on the mainnet. So that's mainly why. So you can write those property testing in different language, depending on the fuzzer, mainly Solidity, and it totally makes sense. And Harvey is also using something called Scribble, where basically you define just on top of the function which stuff shouldn't happen, and they will, I suppose, convert that into something else. As I mentioned, Harvey is closed source. I actually request to get access, but it was too late to test in before the training, before the talk. So I only took a look at the documentation and all the paper related to Harvey to actually find out what they, I suppose, are doing. Then there is some other features that are interesting. You can think of code coverage, Corpus Replay, and gas usage. So I will try to detail a bit more those one. They are not requisites to build a fuzzer, but that's some extra features that actually bring a lot of value when you are doing that. The first one, code coverage. So your goal will be to monitor which opcode basically are executed during fuzzing. So that's a really interesting metric because you can directly flag which kind of function you have not reached at all. And as an as an analyzer to the result, you can determine, okay, I need to improve my fuzzing, and maybe I will need to add some extra testes to actually fill the gap and go deeper in the coverage. So Echidna and Harvey are doing that. For the other one, for what I saw, Foundry is doing that more or less partially, or it's a current development feature. So I suppose it will be integrated later. In the same way, you can have code coverage at different levels, either it will be at the source code level or at the bytecode level. Usually, since they are leveraging on the source code, they are able to provide you this information at the source code level. But it will actually make more sense to do that at the bytecode level to be more accurate of, okay, this specific opcode have been executed and this one not, because, I mean, not everyone knows exactly what the Solidity compiler is doing to their code, except if you are doing analysis of the EVM bytecode. For the corpus and transaction replay, the main goal is you are running your fuzzer, so it will generate a lot of inputs, so it totally makes sense for you to keep them. Just doing that as a one-shot stuff, it's really important to store everything that have been generated, and in the future being able to basically replay everything and not losing all those execution computations that you have done previously. Something else that you can actually do is if your smart contract is actually public, or if you push that on the testnet, you can perfectly extract the previous transaction to the smart contract and put that into your own database in your own corpora. That will be something really interesting for you as well, because you hope the fuzzer to actually took those corpora, do some mutation and manipulation of that, and replay the stuff. So that's some extra stuff for us to basically be faster and go deeper into the program. So again, I will let you check which one are doing what. For Foundry, they are not doing that for the moment, but I think it's a matter of time. At least it's not that complicated to implement. Finally, we have a gas usage report. So you can think it's not something we exactly want to take a look. If you are doing fuzzing, you are maybe only taking a look at vulnerability. But actually, in some cases, you will have vulnerability that will maybe loop to itself and just exhaust all the gas that you have, and it will not be something that will be detected only if you are triggering maybe like a runtime error, like a gas exhaustion. But if you are just before the gas exhaustion, it will not be something you will notice. So in that case, having a gas report and be able to know that, okay, this specific sequence of transaction is actually burning a lot of gas can also indicate you that you need to improve the code on that part, or maybe you will find a way to basically reject the transaction or actually prevent this stuff to happen before. So again, some further are actually doing that. So main question, which one to choose? So that's the global summary of the stuff. Of course, you can see that some of them are really green, and that's nice, especially Echidna, RV, and Foundry, that are, for me, the key contestant in this way. In terms of speed, we can see that Echidna and Foundry are actually really fast. For RV, okay, I don't know. And that's why I decided to put on the first place Echidna. For me, that's the best one. It was one of the first ones. There is a lot of documentation available. It's really complete, as you saw. Is actually filling a lot of the requirement. And it's well maintained, and that's something really important. What I think is the most promising one is actually Foundry. It's really fast. There is a huge community, an active community on it. What I think should be a really good feature in the future will be to add a dedicated fuzz subcommand for Foundry. For the moment, you are using Foundry like doing Foundry test, and it will do fuzzing for you. And as I mentioned, only single transaction fuzzing on the different function of the smart contract. Typically, I think the best new feature to implement will be the generation of sequence and also having the fuzz subcommand to allow people to only use fuzzing and to put that on the CI. Doing fuzz testing like it's done currently, you will maybe do 20 execution, 20K execution on each function, but it will not be enough for you to actually find some in-deep bugs. The last one, based on all the paper I read about the subject, seems to be RV, as I mentioned, closed source. So I was not able to verify that it's actually really working well. So I will expect it to be the case. But yeah, if you are looking to add even more fuzzing and just be more secure, it's definitely makes sense for you to give it a try. So final question, do we need another fuzzer? I think something that is currently missing is maybe a black box fuzzer, like you are only leveraging on the bytecode, and you are doing fuzzing only on that. The only difficulty you will get is regarding the detection of vulnerability, because you will need to detect vulnerability at the bytecode level, and you will not be able to implement property testing. So that will be the downside. But it's still something that is missing, and it could be interesting to actually have that in the future. That's all for me. You have the slides available directly there, and I should be able to take some questions. Thank you.
Questions? I'll ask a question then. So fuzzing is obviously a really important testing technique. Do you think there's also a need for some hard-coded cases alongside that to give users some ground truth, or what kind of approach have you seen with people doing more hard-coded tests alongside fuzz tests?
Yeah, definitely. I think it's a good question. Typically, what I mentioned with being able to detect at the bytecode level, that's something that should actually be done, I think, directly by the EVM. Typically, there is a bunch of stuff that we can just create some general detection rules that can be added to the EVM, maybe in kind of like a debug mode or something, and that means it will bring us for free the detection mechanism. Typically, like reentrancy or this kind of stuff could be detected at the bytecode level, so it could be really interesting to actually have that provided by default for people. Maybe not directly on the main net, because it will maybe break a lot of contracts, but at least inside a kind of debug mode, it will make sense.
Hi, very interesting talk, thank you. A lot of protocols use a collection of contracts rather than just one contract. How would you recommend fuzzing that, like all together as a whole, or individually contract by contract?
Good question. So usually in those cases, that's also why some fuzzers are using the local testnet to actually simulate that. And I think some of them are actually even doing more, that is like cloning the exact state of the mainnet to be sure it will be replicable and perfectly good on that. If we want to do that fully locally, that just means we will need to, I mean, the EVM will do the job in the same way, just that you have multiple contracts. So in terms of engineering, that's not that difficult, and it will just mean the execution, you will not get like direct overview of the execution. And you can actually make it even more simpler with like the generation of transaction, because you can perfectly say, okay, I have like 5 contracts. Sorry, I have 5 contracts, but I will not generate only transaction for one contract, but I want to generate sequence of transaction of all the different contracts. So Of course, it's to be more difficult for the fuzzer to do the job, but that's some like real cases and like potential exploits that can happen in the wild.
Cool, thank you.
Thank you.